This project built a production-ready GitOps platform using ArgoCD to manage and deploy multiple microservices on Kubernetes in a scalable and automatic way. The architecture follows a clean GitOps approach where all configurations are stored in Git as the single source of truth, and ArgoCD continuously monitors and synchronizes changes to the Kubernetes cluster. This ensures consistency, traceability, and reliable deployment without manual intervention. The system is organized into main parts: microservice repository. Each service is maintained in its own repository. Inside each repo, there is a dedicated microservice directory containing application code. Docker configuration. The CI pipeline in its service plays a critical role. It builds Docker images, pushes them to a container registry, and then automatically updates the corresponding values.yaml file in the central GitOps repository. This ensures that deployment configuration always reflects the latest application version. Gitops-platform repository. A separate repository is responsible for managing all deployment. It uses ArgoCD ApplicationSet to dynamically generate and manage applications for multiple services and environments. This approach reduces duplication and makes it easy to scale the system as new microservices are added. Its environment, deployment, staging, and production is fully isolated. This allows teams to test safely in low environment and promote change to production in a controlled and predictable manner. By integrating CI/CD with GitOps, the workflow becomes fully automated. Code change trigger email builds, configuration updates are put to Git, and ArgoCD handle deployment to Kubernetes. Overall, this project demonstrates how modern DevOps teams can build scalable, automated, and maintainable systems by combining GitOps, Kubernetes, Microservice Architecture, CI/CD pipeline, and ArgoCD ApplicationSet. Flow explanation. This flow describes how a piece of code written by a developer is automatically built, deployed, and running on Kubernetes using CI/CD and GitOps with ArgoCD. Each step is connected and fully automated, reducing manual work and increasing reliability. Step 1. Developer push code. The process starts when the developer puts code to the repository. This repository contains the source code of the service along with Docker and configuration file needed for deployment. Step 2. CI pipeline is triggered. GitHub action. Once the code is put, GitHub action is automatically triggered. The CI pipeline performs the following tasks: build a Docker image from the source code, test the image with GitHub, share, and let it. This ensures every change is version and reproducible. Step 3. Put image to Docker Hub. After building the image, the pipeline puts it to Docker Hub. Now the image is stored in a centralized registry and ready to be used by Kubernetes. Step 4. Update the GitOps repository. Next, the CI pipeline updates the value.yaml file in the GitOps platform repository. Location: environment folder. The image path is updated to the new GitHub share. This step is extremely important because in GitOps, you need to deploy directory to Kubernetes. Instead, you update Git and Git drives the deployment. After updating, the pipeline performs as Git push. Step 5. ArgoCD detect change. ArgoCD ApplicationSet continuously monitor the gitops-platform repository. When it detects change in value YAML file, it automatically generates the application using ApplicationSet. Follow the up pattern, create or update application like auth or auth staging. This makes managing multiple services and environment very scalable. Step 6. ArgoCD sync to Kubernetes. ArgoCD then synchronizes the design state from Git with the actual state in Kubernetes cluster. It applies Kubernetes manifest such as deployment service. Step 7. Kubernetes pull the new image. Kubernetes detects last the image that has changed and pull the new image from Docker Hub. Updates the running pub. This happens automatically without downtime. Step 8. Application is running. Finally, the new version of the application is up and running inside the cluster as container. The system is now updated. The deployment is testable via git commit and image that. Runback is easy, just revert git. Demo flow. This demo shows how to set up a complete GitOps workflow using ArgoCD and ApplicationSet, starting from a local Kubernetes cluster to fully automated deployment triggered by code chain. Step 1. Open Docker Desktop. First, make sure Docker Desktop is running. This is required because Kubernetes will use Docker as the container runtime. Step 2. Start Kubernetes cluster. Next, start your local Kubernetes cluster using Minikube. At this point, your Kubernetes cluster is up and ready to receive deployment. Step 3. Install ArgoCD. Create a namespace for ArgoCD and install it into your cluster. ArgoCD will act as the GitOps engine, continuously syncing your Git repository with the Kubernetes cluster. Step 4. Install ApplicationSet controller, which help dynamically generate multiple ArgoCD applications. This is essential for managing multiple microservices and environment efficiently. Step 5. Assign ArgoCD UI. Export the ArgoCD UI locally using port forwarding. Then open localhost 8080. Login credential, username admin, and password. Get it using the command below. Now you can access the ArgoCD dashboard to monitor application. Step 6. Prepare repository. You need to set up 4 repositories. First, platform repository. gitops-platform. Store Kubernetes manifest and application set configuration. Create a GitOps token to allow service repository to update this repo. 2. Service repository. Each service repository must include the following secret: GitOps token to update the platform repository. These repositories are responsible for building Docker image, pushing image to Docker Hub, updating value YAML file in the GitOps repo. Step 7. Apply ApplicationSet. Go to the platform repository and apply the ApplicationSet configuration. This step tells ArgoCD generate the application dynamically, manage on microservice across environment. Follow the GitOps model. After applying, you should see applications appear in the ArgoCD UI. Step 8. Put code and observe. Finally, go to one of the service repository and put a trend to a branch. This will trigger the full pipeline. 1. CI build a Docker image. 2. Put it to Docker Hub. 3. Update value YAML file in GitOps-platform. 4. ArgoCD detect the trend. File automatically sync to Kubernetes. 6. Deploy the new version. You can monitor everything in the ArgoCD UI in real time. Summary. This demo demonstrates a complete end-to-end GitOps workflow. Local Kubernetes cluster with mini-queue. ArgoCD for deployment automatically. ApplicationSet for scalable app management. CI/CD pipeline for building and updating images. Fully automatic deployment triggered by Git change. The result is a modern deployment since that is automated, scalable, easy to manage, production ready in design. This is a solid foundation for building real-world microservice platform using GitOps.